Yeah, so 5 minutes for questions from the last week.
I have one question.
Mm-hmm.
Last week we discussed the hash map, which work as a dictionary key value pairs, but we also have another source like default dictionary, which we can import from collections in the Python. So I just want to understand during the interviews, what is more important? Like in case of default dictionary, we don't need to check whether the key exists or not. If we use default dictionary dot append, if key exists, it append the value to the existing value. If key doesn't exist, it create the keys and then append the value. Basically, we don't need to check whether key exists or not if we really want to add something. But I mean, is these kind of collections preferable during the interviews, or they prefer you to use simple collections, which is not a custom one like hash map, and this is more preferable during the interview? So this is a question.
Okay, I don't have experience in Python. I probably was coding a few times. In Java, we have hash map. So basically, we're using hash map. There is no other alternatives.
Okay.
There is like a hash table maybe, but hash table is very old. I don't think that there is will be. I can like generalize it. There is usually when it comes to algorithm, we're not using any advanced stuff because we have functions and etc. In Java, for example. Me personally, during the interview, I prefer to code very simple, using very simple stuff. Yeah.
Mm-hmm. Okay, thank you.
So, okay. If there is no other questions, let's get started, folks. Today should be not that much that difficult. So the film is quite fine. So I think it should be fine. Today we will cover sliding window.
Lily, sorry to interrupt. Can I just check? Are you recording this before we start?
Yeah. Thank you so much for reminding. I did. Yeah. Thank you so much, folks.
No worries. There's so much going on for you. I appreciate it. Thank you.
Okay, I'm start recording session. Okay. Sliding window technique. This is a subset of two pointers pattern. The one which we cover our first week. I just slightly mentioned that sliding window will be as a subset of two pointers. So now we are going to cover this. Is it 2 pointers? There is we introduce left and right pointers to define a window. Sliding window, it's about defining window over a data structure. Usually it is array or string, so it's also linear data structure. Mansi, can I ask you to mute yourself if you don't mind? Oh, yeah, thank you so much. So when to use it? So basically, sliding window, as I mentioned again, it's work on linear data structure like array or string. So what is like a spot words or spot task? It's asked for maximum minimum sum length. So for example, what is the largest sum you can get from any 5 numbers in a row in this list? Or, for example, find the shortest substring that has all vowels. Or count of substring with constraints, with some constraints. We will cover 3 examples today in the class, and you will hopefully more comfortable with this. And then on Slack, I can share the list of variety of the task, which is can be solved with sliding windows. So has a fixed size window or variable size based on some condition. So basically, there is 2 different types of sliding windows. It could be fixed size, or it could be dynamic sliding windows. So this basically the small introduction. That sliding windows is a subset of 2 pointers task. It's required 2 pointers left or right. It's usually started from the beginning. Both of the pointers are started from the very beginning, and then we are expanding them. I will cover some terminologies which will help you to understand. And there is two types of sliding windows. It's fixed size or dynamic sliding window. Now let's cover some terminologies which will help us during the solving task. So expand. To expand the window is to advance the right pointers. So once we will introduce left, we will expand our window. Expand means moving right pointers toward the end of our data structure. To shrink the window is to advance the right, there is mistake, it's to advance left pointers. Actually, to shrink, 1 second. To advance the left pointers. So we are shrinking window, we are making it shorter. Here we expanding, we make it longer. To slide the window is to advance right and left pointers at the same time. So we're basically just sliding these windows. At this moment, everything is clear, or you have any questions? Okay, cool. Moving. Okay, let's now just dive deep a little bit into fixed sliding window, and then we will dive deep into dynamic sliding window. A fixed sliding window maintains a specific length as it's slide across a data structure. Usually in the task, you will see that will be fixed requirements that you have a window, for example, the length of 3. Then you can like straightforward think about fixed sliding window. So first, obviously, when we introduce our pointers, we first need to expand window. Then, once we will expand to the required length, we will start slide this window. So we use technique when the problem is asked to find the subcomponents of certain length, as I mentioned. And there is some code, snip of code, which is usually we use during the solving of task. So we define it left and right, which is pointed to the 0 index. Then we introduce loop where we are moving our right pointers. So we started to expand our window, and then we're checking if we reach the desired size or not yet. If we reach them, then we do some processing, like we invoke some function, which is required to find some solution, which is is an input of requirements of our task. Then we're receiving result, and then we're starting to slide. How we're sliding? Once we reach the fixed size, we check result, and then we are moving left pointers. And after checking this, we are moving right pointers. Does it make sense? Okay, moving. Now, dynamic sliding windows. So at the first, initially, we also defined left and right, which will point it to the 0 element, and we start to expand them. But instead of slide, depends on the condition, we will shrink. Once we will go out of the condition, which will satisfy us, I will show code, it will make clear. So we will start to shrink this window once we go out of our condition. If we still satisfied to our condition, then we will expand. So there is basically 2 branches of the decision which we need to take. Okay, this is the code. Left and right point to 0. We're starting our while loop, where we are tracking if right is reached the end of the string. And there is our condition. While condition is whileed, so we are shrinking our window. We are moving left pointer. If everything is okay, once the window is valid, the process is then expand window by advancing the right pointer. So is it clear? Okay, cool. So basically that's it about the terminologies. And now we will move to our first task, which we're going to solve this week. You should have, 1 second. I also link the HackerRank link. So this is the one, the first one, which we will cover. Here will be slightly tweak. Instead of now, I will explain that there is with a slight tweak, but will be almost the same task. So we are given two strings, S and N. Both consider of lowercase English later. Return the number of substrings in S that are anagram of T. Anagram is the word. So we covered last time what is the anagram, right? Folks, do you want to cover me again? What is the anagrams mean? Okay. So this is the main string, and we're giving T. And we need to find how many substrings in the main string we have, which is satisfy our condition, which is anagram of this string. So as you can see, this one is our first anagram. And then there will be another one, which is also our anagram. So basically, there is two substring, which is anagram of this small string. From the description, is it clear what we were asked to do? Okay. Let's go to our intuition. So we can look at an anagram in different ways. A substring of S is an anagram of T if it uses the exact same character as a T, just in any other order. We also were covering this a part of last week. So we just care about the latest. We are not care about order. For a substring in S to be an anagram of T, it has to be the same length. So let's call it len T. So we only need to check the part of that exactly length T characters long. This means we don't have to look at every possible substring, just those of the right length. So there will be fixed length. To examine all substring of fixed length, we can use fixed sliding window here. So this is the example. We will slide over the string in order to check every possible substring, whether they are our anagrams. Now we just need to check, as I told, if it's anagram, how to check it. So just 1 second, if we compare how often appear. Okay, let's see how it will expand. Yeah. So basically, just will sum up what I just told. So we have string and we have small string. We are okay about the length of string. It should be anagram. It should contain the same exact numbers of letters with the same frequency, like in the T, right? So basically, this gives us a call that we can use a fixed sliding window. Now we need to come up with a solution how exactly to check if this substring is actually our anagram. For these things, usually it's not only related to sliding windows. There is some technique which exists. At the initial description, you had this one of lowercase English letter. So we can introduce 20 array, which is will size of 26 numbers. Why? Because from the description we know that it will include only lowercase English letter. So in this strict number, this is quite frequently technique which is used for different kind of tasks. So then we're introducing array size of 26. We walk through whole the array and we count the frequency of these elements. In this case, we are not we need to define frequency of this string at the first place. Then we will have this array where we know that there is array which is contain A2, B1, C0, and Z0. So this is the array of 26 of size, including all the letters. I will explain how we usually do this. Just 1 second. So in Python, we will use this formula to count, to find the index in 26. And in Java, I usually use this formula. So we're taking from our string first chart, 0, and we extract A. And it will look like this. So 99 minus 97, it will give us 2, which is will give us the second index in the our 26 size of array. So let me show you how how in the code it will looks like. So that's how we are going to populate this array. We first created size of 26, and then we are going to populate. Now, somewhere here, yeah, this is Windows frequently already, and this and at the end we will receive this array. Is it clear?
No, sorry.
Okay.
I have a question. Is the problem saying that if in a given string, the letters of the anagram can be out of order as well? I mean to say that not continuous or contiguous.
No, substring should be continuous. So at any time we will look into substring of the fixed site.
Okay, so what is the need to do expected frequency? Because why I'm asking is, couldn't this problem be done as, so do the sliding window, but as you look at each window, all you have to do is arrange the letters in sorted order and compare that with the letters in the expected string, right? So for example, given we have ABA, so if we sort that, we will get AAB. And so every window, as long as we look at AAB in the sorted order, we should get the answer. Why do we need an expected frequency here?
Because that's how you will reduce the time complexity. So initially, before entering the loop here, you will pre-compute your expected array here. 1 second. It's right. You're absolutely right. You can solve like this. But every time when you're sliding the window, you need to sort the string and make equals with your expected string.
Yeah.
So this is about just to save pre-compute time. Here we will create, at the initial, we will create our expected array, and then we will do Windows frequency array, which is we will fill out. But because we will not always fill out it with the frequency, we will not going to start it from the beginning. But once we will shrink the we will slide the window, we will remove the left pointers from the window, and we will populate right. And so it is from the time complexity. But you're absolutely right. You can solve it this way, which you mentioned. And instead of using actually expected frequency, for example, here array, you can use hash map like we use before in our previous week. So you can populate the later, and you can populate the frequency of this number. But again, expected frequency at this time, because it's the fixed size 26, we are count it not like space complexity or 10, but we count it as a space as a constant space complexity, because it's just 26 numbers. So it's a pure optimization.
Okay, so I understood what you explained, but I have one more question. So we are still sliding the window all the way to the end of the string, right?
Yes.
We're not, I mean, where are we saving the time is the question. Is the sorting alone the saving of time, or?
We are not sorting. I will come. I'm just covering the first part. What is the expected frequency? And this is kind of technique which is nice to know, because this is very optimized, and a lot of tasks where we are using this technique. We are building array instead of using hash map. So I just basically wanted to explain this part, and now I move to the algorithm.
Can you just explain how you built the expected frequency and Windows frequency array? It wasn't clear to me.
So you have this D, which is your initial one, and you need to count frequency for your expected array, right? So you introduce the size 26, and you walk through of your array. And as I showed it, formula, which is we use in Python. In Python, we use this formula to populate this expected frequency array. And in Java, we use this one. So that's how we are built our expected frequency array.
Yeah, and the window frequency, can you show them? Yeah, so how?
I didn't yet land to this.
Okay, sorry, yeah.
Yeah, no worries. So this is clear about how we built expected frequency array, folks.
Yeah.
Okay, moving on. So to start sliding Windows algorithm, we need a few things. As I explained it before, so we need left and right pointers, both start at the beginning of string. Then we need to introduce Windows frequency, an array again with 26 spots to count how many times each letter appears in the current window of this string. So once we will start, count the variable keep. So now let's get started. This is 3 steps, which is I cover here. So we will start it initially. Also, just to make it comfortable and clear. So we start our function here. We build our expected frequency arrays and Windows frequency array. We populate at the beginning only expected frequency array. Now, from here, we are starting our sliding window algorithm. We initialize our left and right, and we start our while loop. So at first place, we are expanding our window, and we count frequency of each element until we reach to the point where we are having the same length as a T string. So once we reach to this fixed length of length T, so we can check if length T, if expected frequency in Windows frequency array are the same. So if it's the same, what we're doing here, we are, as in this case, it was asked just to count how many substring. We are just increasing count if we satisfy the condition. If the condition is not satisfied, then we are, and if it's not satisfied, whatever. So at this moment, we just check. If it's satisfied, we're increasing count. If it's not, then we are not increasing count. But anyway, we are sliding our window for them. So this is the step. So we expanded, here stop. We reach our point, and now we should take decision. So we check our first window. Window frequency are not the same as expected. This one our expected frequency array, And this is our window frequency. It's not the same. So we are continue. Continue means we just sliding window. Here we're building another one. So we basically just remove C from here and we update with B. How it's done here. So we're taking our frequency array. We are also the same formula we use here. We count the index and we are removing frequency because currently we are just slide window and the one which was under left pointer chart, it's no longer will be in our window because right after decreasing the frequency, we are moving, we are sliding our windows by increasing left pointers and then right pointers. Is it clear, these particular steps? Because it's very important in sliding window.
Yeah, I have one more question here. So if the frequency was 2 for that letter, are we incrementing only 1? For example, if the initial window had a string like CCA, right? So that would have been 102, correct?
1 second. CCA?
Yeah, if we had this as the substring, the window that we're looking at, that would look like 102 and so on.
It will be like this, right?
Yeah.
And once we will shrink this window, so for example, we are moving this one, C is excluded, right? We need to update this window and it should become our, because A is still here, B is not here, but C is only 1 in this case. So we make it C. But if here we remove the window and next one will be B, then we need to update here to 1.
Okay, that makes sense. Thank you.
Yeah, no worries. So this is particular steps, how it will be looks. And there is how the frequency will be updated on each step. So basically this is the whole algorithm regarding the fixed number. We can walk through one more time just to sum up, then I will take some questions. There is some slide optimization, which is we can done. I mentioned it here, a small optimization. At the initial step, we can make it, so we are compare here, because we have this T. If T is bigger than length S, then we right away should return 0. Because we can't make anagram. There is pure optimization. You can forget about this optimization during the interview. I just mentioned it. So this is next. You introduce count variable. You introduce 2 arrays, which is expect frequency and Windows frequency, both 26 size, just because of we have in our description lowercase. If there is no lowercase and it is including uppercase as well, so you can use hash map at this sense, because if it's case sensitive, then this tweak won't work. But if lowercase, it's 100% that during the interview you will interviewer probably will expect from you that you know this technique and you will introduce the array of fixed size in order to reduce the space complexity. So then you initially populate your expected frequency array. Then the sliding window algorithm started. So we introduced 2 pointers, left, right, which is point to 0. Then there will be loop, which is right less than length. Satisfied while we are looping while we're satisfied to this condition. Here we will populate our Windows frequency. We will start from the right pointer. And then we will check. Once we reach the condition of length T, that our window is the length T equal, then we will check if this window is, if window frequency is the same as expected frequency. If it is, then you will return count. In homework, you would need to return index. Where the subarray string is actually substring is actually started. with slight tweak. So basically you need to tweak it somewhere here. And then, so whether you satisfy this condition or not, we anyway slide our window. Before slide our window, we slide it by increasing left pointer. We need to decrease frequency because we are moving out of this window. So this is important. The order is important. And then after the whole loop, you just return the count. Yeah, Moina, I can explain one more time. So basically, you have initially long string S and T string. So based on constraint, it's not 100% that S will be longer than T. What you can check at the beginning, if length T is bigger than length S, so for example, you're asking here, whether this one, this our S, and here, for example, CBF, it's our T. If in this S string you have you have anagram of string T, apparently you don't, because this one string is longer than the S1. So we can't find any substring of this T. So this is a small optimization, and you just return 0 at the beginning.
Thank you, Lilia.
No. So I'm done with explaining this task. Any questions?
Yes, can I ask a quick question?
Sure.
I don't quite understand. So with the expected frequencies where you have odd C minus odd A and like odd right minus odd A, I don't understand what that does. And then the plus equal, I know what plus equals 1 is, but I don't understand the order and minus part.
This is Python. Are you, which language do you use?
C#.
Oh, okay. Probably it's similar to Java code. In Java, we're using this one. So the idea is, 1 second, where it is? This one. So we're using these values of ICCs. In Java, how we are char at I return the character at the position I in the string. When you so basically, when I'm doing this as char at 0, which is pointed to char C, from this table, let me just Google this one table. You will see. See, for uppercase, we have 65. For lowercase, we have A, which is equal 97. Do you see, right, my pointers? And B,
Yeah.
it is 98. So we're using this table in order to fill up our array with the condition. And there is, so we're usually using this formula. It will be always A, which is we're extracting from. Because, for example, C is equal to 99 from this table. Let me link it. So it's pointing to 99 and minus 97, so it will give us 2. And we can put this index, we can use this as an index in our frequency array to fill up with, so to fill up it with to create this array. So in this case, in this size of 26. Does it make sense or still not?
Sorry, Lydia, I have one question. I understand how to calculate it, but I don't understand why we always want to deduct A. Is that because we will get a simplified number, or?
Yes.
Oh, thank you.
Because it's if you will walk through, so for example, B, it will be 89. And if you will extract, it will give you 1. So then you will have then it's A, B, C, D. So minus it will give you 3 here. So basically, you can look at this, and that's how this is increasing by 1, and that's how you can find position in your fixed size 26. And when it comes to Z, so it will be 120. 1 second. 2020 minus. So it gives us 25. And this will be our the last position in our array. But it will work only if condition is asked for lowercase. But if it sounds complicated for you folks, you can use always hash map here. So with hash map, it will be just you will introduce key, which is pointed to char, and value will be your frequency. So basically, you can use here A, which is, for example, frequency 1, and then B. And when you're doing conditions, so basically, yeah, you can use a hash map in this case.
Thank you.
Lilia,
Okay.
hi, Lilia. Quick question. You said we only use it for lowercase. Can we use it in other instances as well, though? If it was all say uppercase, the same thing would apply.
No, I don't think with the upper C. If you will have uppercase and lowercase, so there is should be I guess 52 size of the array, and I don't think that you can use the same formula to find out the index.
And then in that case, use hash map. Got you. Okay, thank you.
Yeah, no worries. On your questions, you can totally try with hash map, or the same way like Moina explained it before. It's also one of the solution where we just sorting our string, and we just make it equal or it's not equal. So it's totally fine to solve. But most likely during the interview, it doesn't mean that it won't be hired or not hired if you do not come up with this solution. But most likely, once you will see this lower English letters, it's most likely in any case. It doesn't in any task. It could be not for sliding windows. Most likely, it will be expected that you know this technique. Yeah, Mansi, you can ask question.
Yeah, sorry, it might be repetitive. Even if we go for the low uppercase letter also, then also the size of the array will be 52, and that is also a constant size. So
yes, but how you will define the formula? How you're going to fill up your frequency array?
yeah, but then you're right. Then we have to firstly need to know whether it's uppercase or lowercase.
Yeah,
So
yeah.
actually subtract the lower index. Okay, I got it.
Yeah, this.
Yeah. Thank you. Yeah.
Oh. So moving on, folks. If you want, I can post something, maybe deep dive on this technique on the Slack. Okay, cool. But once you will take, for example, just take this table and try to draw on the paper this is formula. Also, I put some example from Python and from Java. Probably in C# you also have this char add. I'm not 100% sure. So just find what exactly on the string method return you this value from this table, and that's it. So basically, you can use it. Okay, moving. Now we will cover task for dynamic sliding window. This is very popular, and it has different variation. I took the one which is with unique character. But sometimes it's asked with no more than two duplicate characters or something else. And they usually solve with the same code, just with some small tweak. Okay, let's walk through the description. You're given a string. Determine the length of its longest substring that consists only of unique character. So you have string, and this will be output, which is ABC. Is the longest substring of the length 3 that contains unique character. The rest will be contain duplicates value. So here you can see its longest substring. Means our target is to find longest one. Then it's 100% sure you could be that it is a dynamic window. Okay. The brute force approach involves examining all possible substring and checking if any consists of exclusive unique characters. Let's break down this approach. Checking a substring for uniqueness can be done in over 10 times by scanning the substring and using a hash set to keep track of each character, where n denotes the length of S. If we encounter a character already in the hash set, we know its duplicate character. Iterating through all possible substring takes O at 10 quadratic. This is the brute force solution. So here, this is our function, which is defined. So it's checking if it's unique or not, and then you're in quadratic time, just trying to find out if all the possible combination, if it's unique, if it's contain only unique or not, and then you just find the max. So and return. Yeah, but with executing this function, it's all actually n3 will be. So this is the brute force solution. Let's moving. Sliding window. Sliding window approach can be quite useful for problem that involves substring, in particular because we are looking for the longest substring that satisfies a specific condition, contains only unique character. A dynamic sliding windows algorithm might be the way to go. Okay, we can categorize any windows in two ways. With no duplicates and contains at least one character. B is duplicate. If B, yeah, just 1 second. Let's try this strategy already following. Okay, we can, yeah. So at any point in time, we will have two windows. One which doesn't contain duplicates yet, and one which is already contained. If A is true, we should expand window, right? Because we know we have window which is still not which still contain only unique chars. Then what we need to do? We need just to expand window, because our target to find the longest one. And if we have window which is already contains duplicate, then we know that we don't satisfy the condition which is asked. And then what needs to be done? We need to start shrinking our window until we will again satisfy our condition. Means we will shrink until this window. I will deep dive now here. This is the strategy, how to solve it. Yeah, so is it clear at this moment? Okay, for those who is still not sure or not comfortable, I defined all the steps. It's the same. All the sliding windows start with the same. We define it left and right pointer, which is point to 0 elements. In this case, we will use hash set here. I'm not sure if we can use this technique or not. There is nothing is told about the frequency elements. So that's why we are using hash set here. Okay, So we will start from A. Our hash set is empty here. A is not in the hash set means we're expanding window, we're putting A into our hash set. Then we're expanding window, we reach B. B is not in the hash set, we're expanding window. C is not in the hash, we're expanding window. Once we reach the B, we know that we have in this hash set bit. So what we need to do now, we need to shrink our window like this, in order that B in order that we remove B. So basically, I will leave it like it is. That's how we will shrink window. We will shrink. We also need to care about A because we are shrinking window. We're shrinking from the left. Do you remember how we were sliding? We were in sliding. We were increment our left. This is the same thing. First, we expanding window means we are moving right pointer, and now we are shrinking window. We are moving left pointer. We're moving left pointer one by one. So means we need to remove from hash set our element which is out of our window. First it will be A, then it will be B. B is not in the hash. Once we shrink the window, we remove it, and now we know that there is no longer duplicates in our hash set. I will explain in the code how we check it. And we decide to moving forward to expand our window. So we are expanding C, B, and A. This is our code. Let me just walk through to make it more comfortable. So initially, we defined hash set. We're defining our output, and we're defining our right and left pointers. Our loop, from here, we are again starting our algorithm, which is sliding window. So we are defining while loop. We are taking the first character, which is right. We are checking in the hash set if it's contained in the hash set. Shrink window until current char is not set. It's not here. And if it's not here, we are moving to this one. We are adding to hash set. And then we count our max length at this point, and we are expanding our window. Once we reach to the point, to this one point, to this, we will reach to this condition. So here, while hash set, we will loop until until this element, which is 1 second. I will take it in the example. So we will reach to this condition once we will encounter B, which is already contained. We enter to this loop. Here, our current char, it is B. And we will trying to shrink our windows until we will remove this B from our hash set. Means at this point, we will remove first A, and then we will remove B. And we will move our left pointers. This is important to understand how we advance left pointers when we will encounter a duplicate. Is it clear, folks?
Where are we storing current string? Like suppose A, B, C, B. So we encounter B. So we need to keep A, B, C somewhere.
Say again, please.
Are we not storing what we read in window? Like, are we storing ABC? So because until now, ABC was the highest amount of unique character string.
Yeah, we don't need to store the whole string, because in this case, what is asked just to remove the longest substring the length of the longest substring. You don't need to return the whole substring. I mean, because, for example, ABC is our longest. There is ask just to return the max length. We are calculating max length here. We're always updating it after we are doing any manipulation. So at the beginning, our max length is 0. Then once we will do any manipulation with window, we'll compare if our right, so how we define the length. We have our right and we have our left. And we calculate our current substring length and we compare with the previous result of max length, who is bigger. And so, for example, it is very fine that at some point there will be, so for example, 0, and at some point it will be 1. Then your max length at this point will be 1. On next iteration, you will have comparison between 1 and 2, and your max length will be automatically updated to 2. Then it will be free. Then you will shrink your length, but your max length will be still free. So at some point you will remember, for example, next after shrinking, your max length free at this moment. This is the biggest result which is you so far found during the iteration over the string. And for example, then you shrink the window and it's return you 2. Then you're just not updating with the 2 because we're asking for max. We will keep free until. So it's fine if you encounter your first substring at the very beginning. You will remember it because we want to use only max. So if after the beginning substring there will be 1 or 2, it won't update your result. And at the end, you will just return free. So you not ask return the exactly substring, you ask to return the max length. This is a good question.
Oh, got it. Thank you, Livia. I missed that actually. Yeah.
No, I also miss it, but it is also very important. Folks, do you understand this part? So any other questions? Because this, yeah, any other questions? So this one is very enough for interview, absolutely enough. I'm usually, I didn't know until I was prepared this lecture about the optimization, which is I will explain next. How we can optimize further. There is some small optimization which we can do. That's why I emphasize on this part a lot. So you should understand that we will shrinking one by one element until we will find duplicate. So this part we are going to optimize. But this is more than enough for interview. I usually use this this pattern of code in my to solving this task during the interview. But there is, yeah, we can move to the small optimization, which is where we optimize this part. Instead of shrinking, as I explained it here, so in previous approach, we respond to encountering a duplicate by continuously advancing the left pointer to shrink the window until the window no longer contains a duplicate. So for example, if we take this example, our left and right, and here we encounter C as a duplicate. In order to shrink, we need to remove A, B, C. So and then we will shrink eventually in order to satisfy the condition where the string is not it doesn't contain duplicate number. So instead of using hash set in this case, we can use hash map. So just 1 second. Yes, hash map. So it looks like an array. I'm not sure because I'm using Python. But if you will take a look at the Java, so we're using hash map in this, where we have k as a character and integer for keeping index. This is not for frequency, but for keeping index when we first time see this element. So in the risk could be two situations. So for example, we take C. C at this moment, 1 second, will be our free. It's index not of this C, it's index of this C. It is free. And we check. We know that our left pointer at this time is pointed to A. And our C, first time when we see it, it's equal. It is equal to free. In this case, we know that duplicate why C, because we found out that we have one C in this substring. We saw it. That's why we're working with C. So we're asking our hash map, what is the index of our first occurrence of the C? It's return as free. We are checking with left in order to determine if this duplicate is inside window. So based on this situation, the C is inside of the windows, duplicate in the window. But if we will take a look at this example, here we are encountering A, for example, and we're checking if previous index of A, where it is. It is 1, and it is not in our window. So it is outside of window. So there is everything is okay, not duplicates in the window. So how we did it in this? We were tracking hash set, and we were removing our duplicate for hash set, and then we were populating again in order to track duplicates. In this case, instead of using hash set, we're using a hash map. We are populating first occurrence with first index, and we leverage our hash map to check if it is contains to check our substring window. If it is, then instead, so it's all done purely instead of doing it in the while loop. We now have if. We are not looping over the whole substring, and we're just taking this index. In this case, we will take index of this C. It is free, and we will shrink these windows right away by 3 plus 1. So it will be this shrink. Instead of doing while loop, we are just taking index. We are not excluding these indexes in the while loop, and not endless checking our hash set. We're just taking index, and we are and we are assigning our left pointers to new index. Is it clear? Okay. This is the very small optimization, which is you can feel free to skip, because this one is good enough for code interview. So any questions about this task? Because I'm moving to the third one. Okay, cool.
Just one thing to confirm, sorry.
Sure.
So does it mean as per the new optimization, we are just maintaining we are just incrementing the left pointer to count the current maximum length in the hash set? Like rather than deleting each and every characters till that particular duplicate one, we are just moving the left pointer to get the latest window size. Because here you are putting left is equal to previous index dot get current character plus 1. So here we are updating the left pointer with the latest character index in the hash set. Can we say that?
Yes.
Okay. And you are then updating the previous index value also with the latest character index, so that we now have the latest index of that particular character in the string.
Yes, at the
Okay.
end, you will update it. But first, if there is duplicate, you will always hit this condition, always. But yeah, at the end of every loop, you will update, you will take your current char and you will update with the index. So in this case, because you, again, there is order is important. First, you will hit if there is duplicate element, you will move your left pointer. And if there is duplicate, means you already shrink, you can confidently update your current char with the right. Means in this case, we will first shrink this window, and then we will update with the another index, this C on this row.
Okay, I got it. Yeah, thank you.
Lilia,
Mhm.
can you explain the improvements to me with regards complexity by time and space? Whereas initially we were talking about using hash set over hash map, that it was more optimized, and now we're going back to hash map. Can you just, and so I'm clear in my head, clarify the change in optimization and all those different approaches?
Let me just to think about the worst case. When we will, for example, encounter duplicates at the end of string, and for example, we need, so it will be almost n quadratic, I believe, here in worst case. So for example, if you will encounter at the end, so for example, if we will take just 1 second, let me think through. Do not lie. Let's take this example, A, B, N, G, and D, for example, and here C. So if we will take this one, we will walk through, because to this substring, we will keep expanding, everything is fine. It will be O10, right? Every element. But then we encounter duplicates, and we not yet know in our condition that C is duplicate is at the end of our length. Means with the above code, without optimization, we will keep shrinking, right? Everything. So means we will again walk through the whole string. We will keep shrinking. No, C is will be it will be enough just to shrink here. So it will be not n quadratic. It will be probably kind of like this n. I think this would be the correct saying. N multiplied by OM by multiply on O multiplied by M. Where is M is the length of our substring. M will be here our substring. Does it make sense? We usually saying this way. M, it will be the length of substring, because you need to shrink it and walk through all the elements. So it will be n multiplied by m. And when we will come with optimized solution, so it will be O at 10, because here we're just checking if.
Okay, thank you. I need to go away and think about that one. Sorry. Thanks. I'll look back.
Okay, folks, moving to the third one. So, description first. A uniform substring is one in which, so 1 second, if it's description is correct. Placement, I think this one, correct. Okay. This is the right description, and this one defined the terminology, what is the uniform string means. So given string, determine the length of the longest uniform substring that can be formed by replacing up to k character. A uniform substring is the one in which all characters are identical. So if we will take a look at this example, we are given string and we allowed to replace at most 2 elements in order to make the longest uniform substring out of this string. So in this case, we can achieve it by replacing this B and D with S. Then we will receive the longest uniform substring. We can replace B and D with A, then it will be 4, because the last A is not a part of this substring. Uniform is also continuous one element, so they should stay together. Description is clear, folks?
No, sorry, I didn't really understand what you explained about the last A.
Yeah. So, for example, uniform string is understandable. What is this? It is a substring is one in which all characters are identical, and all characters. So, for example, this one, it is not uniform string. This one is uniform string. So, because here we have B and we have A. Now we will ask to return the longest uniform substring here. There is multiple options which we can make as uniform. It could be A, where we replace, and we allow to replace 2 characters. In this case, K, it stands for how many characters we can replace. So, for example, we can replace B and D with A. Then we will receive this initial string, which is modified, and the longest substring will be 4 characters of A. But we can find better solution. So, for example, B and D, if we will replace with C, then it will be length 5. This is the longest one substring in our which we can do by replacing 2 elements in the string.
Okay, that makes sense. Yeah.
Okay, cool. Moving. So, intuitions. So when we receive a string, right? So first, it's obvious there is 3 options which we can replace. It's either we're taking for example this example. We can replace A, we can replace B, or we can replace C, because this string contains only those elements. The most efficient choice required the fewest replacement, and to make all character A, which involves just 3 replacement. So 3 options, A, B, and C. The most efficient choice, because we are limited in our replacement characters, to make the fewest replacement. And also, with fewest replacements, we want to replace, probably we want to try with the max frequency elements in the string, which is not the case here. Here was, it's almost the case. They are both frequent elements, A and C. So to make all characters the same, replace every character, expect the most frequent one. So 3 options, A, B, C. Then we want to replace as few as replacements to make. And probably it makes sense to replace the most frequent elements we have in the string. But it is very depends. It very depends on the string. It's not always the case that most frequent element will work. So it's also required some dry run on paper, even for me. I think it's not always the case.
It's because even if we take the most frequent letter, the problem is that they may not be adjacent to each other,
Yes,
right?
exactly.
Okay.
Yeah. I think it won't be the case over here. So, for example, if we will add A, we will still, yes, even though we have most frequent A here. So, yeah, this is not the case always. Okay, so we can, at least we can define some one second, some formula. I'm trying to, so substring length and max frequency. Okay, at least, yeah, not in the whole, at least not in the whole string, as we discussed here. It won't work here, right? But if we will, because we're going to use a sliding window, then this technique will work on the substring. In this case, we take the substring, for example, we have 2A and 1B. At this point of time, we know that top frequent elements is A and 1B. So it makes sense to replace B with A in this case, right? So when it comes to the substring, we should consider, we should track max frequency element in it, and then we can use this formula to see one step back. Regarding the substring, is it clear why we need to target max frequency element in the substring?
But sorry, I didn't understand how you're choosing the substring.
We will use a sliding window. I will move to this.
No, I mean to say, what is the length of the substring?
We will our goal is to find the longest one.
Correct, but when you are sliding the window, what is the size of the window?
It is dynamic window because you are looking for longest substring.
Right.
And if we will look for fixed sliding window, this is the first task where we were covering the fixed sliding window. But in this case, we need to find the longest one.
Okay, so you're saying that we will slowly, we'll start with one character in the window and we'll keep adding, and then we'll expand or shrink based on a condition.
Yes. And each substring, we will target our max frequency element in each substring.
Okay.
Means we will start from A, there is will be A, then we will expand, will be B, so they both will be have frequency 1. It doesn't make sense for us, makes the difference. We can replace either I or B. Max frequency will be still 1. Then we will expand. We will look at this substring, which is ABA, which is A2 frequency, and this one is 1 frequency. We will take frequency element of 2. Does it make sense? What is the behind chart we have here? We just need to find with this formula how nums char we need to replace. Why we need this? Why we need to find this answer in order to decide whether we are going to shrink our window or we are going to expand our window. The same way we did with unique character. We need to find out at which point of time we need to shrink or expand. Yes, so we keep track the highest frequency in any substring. So we're just defining formula now in order to decide how we are going to adjust our sliding window. So, as I explained it, if nums char is still less or equal k, we can make a substring uniform. If we're above of num chars to replace, we cannot. So we're taking substring length, we're excluding max frequency elements in this substring, and we find how many chars we need to replace, and if this substring is still valid for us. If it's still valid, so we will update our max length as we did for unique character as well. We will keep track our max length because we need to return the longest one. And if we will out, so we should shrink our window in order to, again, to find our window which will satisfy this, this condition. Does it make sense at this point? We will go deep now into code and all steps. Okay, cool. In order to track high frequency, we will again introduce our hash map with the frequency of the element, where we will track if char and number of frequency in the particular substring. Means once we will shrink our window, we should take care about our hash map and remove frequency of the elements which is out of window. So it's pure. So these steps we already seen in the previous task. Okay. So yeah, it's the same what I just did tell. So we can use the above condition to determine how to expand or shrink window. If the condition is met, the window is valid. We expand the window to find the longer window that still meets the condition. If condition is volatile, for example, windows is invalid, we shrink the window until meet condition again. Let's look at the example. We have this example of the string, and we allow to replace just 2 characters at a time. The same technique, we introduced left and right pointers, which is initially pointed to the 0 index, which is A. Now we have our formula, which is we defined it above, to track if we still meeting our condition for our substring. So we are tracking window length, and this will be 1. It will be right minus left plus 1. And minus 1, it's a frequency of this of the highest frequency of the element in this particular substring. So it will be 0, and we still can expand. Next, we are expanding our window. We calculate again, we satisfy our condition. Next, we will again expand. We still calculate. I omit some steps. And now we reach the point where we are not satisfying our condition. At this place, we have, in this substring, we have the most frequent elements 2 and unique elements 3. We are doing our calculation, and we know that we are no longer satisfied this condition anymore. So we need to shrink our window. After shrink the window, so for example, as I explained it, we shrink the window. First, A is out of our window. We need to update it. So how it will look in the code? If nums chars to replace is bigger than k, so we just will remove from our hash map one of the accuracy, and we will increase our left pointers. There will be some. Focus with me. Any question on this, because I will move to something important now.
So before we started this this while loop, we already created a hash map where we went through the string and we created a map of every letter.
No, we will do it during the computation. This is the code, a good question. So you don't need to do it before computation. So we just initialize our frequency map. Here it's empty. you introduce highest frequency and max length variables, where you will track high frequency elements per substring, and when you will track your max length so far. You will introduce left and right pointers, which will point to the 0, and then you're starting your loop. So update the frequency of the corrected right pointer at the highest frequencies for the current window. So first, we will update here our map. Then, as we tracked on each iteration, our highest frequency in the substring, you will find out if your high frequency is actually changed. So for example, let's take this example. We have A, we have C. So over here, it will be, you will compare here. Your max frequency will be 2, and new frequency of C, it's 1 at this point. You're not going to update, because here is max frequency is 2. Next, it will be 2 and 2. It's again, because we are not targeting any elements, whatever we can replace either I or C. So for us, it's not important which element currently is frequent. But once we reach to the point where we are comparing our frequency element, here will be 2 and 3, your highest frequency will be 3 at this point. So you track your high frequency, you're updating your hash map, then you're doing the calculation, how characters you need to replace. You compare your condition, if you still satisfy your condition. If you're not, then you need to shrink your window. So first you will update frequency of the element, and you will move your left pointer. It's very similar to what we did in our previous task. Moina, did I answer your question?
Yeah, thank you.
Okay, cool. Now we have some small observation for this task. Our goal is to find the longest substring, which is meet the condition. So shrinking the windows might not even be necessary, because at any point of time, we will find our max length. And we can, instead of shrinking, we can just sliding our window, because we found already the longest one at some point. And why all of a sudden we will shrink? We don't need to shrink. We need just to slide them. Does it make sense? Or I can show examples. So in this case, so for example, if we need to replace, we are no longer satisfied. 1 second. Let's say we found our max length here, which is will be 4. And once we reach to this window, we are no longer satisfied. Before we were just shrinking our shrinking our window. But instead of shrinking, because we need max length, let's just slide it. Again, here we are not satisfied, right? Because we need to replace even more elements. Then we will just slide again. Here we again satisfy it. And once we will satisfy this condition, we will expand window. So instead of shrinking in this case, we will slide the window. And once we will satisfy back, we will expand our condition. So this is kind of slightly hybrid approach between of fixed size and dynamic size. Because in the fixed size, we were looking for the fixed one, but now we just combine those two approaches just for different conditions. But both will work. You can shrink, but it does make sense. Just does make sense because we are looking for the longest one. So I'm done. with my explanation. Any questions?
The intuition seems to be same as the previous one. In the previous one also we avoid the shrinking and just update the pointers with the latest index so that we don't need to run the while loop.
Yes.
Yeah, okay.
So if no other questions, this is our week 4, just 3 tasks. This one with a slight tweak, the rest is the same. And I believe there is no issue with ordering. There is one issue with ordering, folks, because I don't know how to solve it. And we always ending up with ordering. So I put it, order is important, folks. During the interview, it's not really important, but because of I don't know how to fix it on the HackerRank, order is important of the indexes here. Yeah, but it was fine. It's a not difficult one pattern. So for me, I believe dynamic programming and graphs is the most terrible one, but the rest is fine. Binary search is also a little bit terrible, but the rest I believe it's fine. Just to need to break down in simple explanation. So we can finish then, folks, a little bit earlier. And I hope, yeah, thank you so much, folks. Thank you. I'm stopping recording now. In 2 hours.